Are you and your computer having trouble communicating? If so, it may be time to talk to your computer about data. Welcome back to Learning with Merit. I am Mr. Merritt, and today we're going to deal with representing data on Python Interpreter. In Python, there are what I like to call 6 beginner data types. We have Booleans, which are true or false values. We have integers, which are whole numbers. We have floats, which are numbers with a fractional part, also known as a decimal number. Don't want to get that confused because later that's going to come up. We call them floating point numbers. Then we have characters, which are single length text, basically, where we have quotes around that, and they can be single or double quotes. We also have strings, which are literally multiple characters strung together. That's why they're called a string. You can think of that as any text. Again, we can use single or double quotes for that. Then we have lists. Now, these lists are going to be enclosed in square brackets, and inside of those square brackets, we will put values of any of the other data types. That means we could use Booleans, integers, floats, characters, strings, or anything else inside of that list. Now, lists are going to contain multiple items called elements, and each list is going to have indexes or numbers associated with a spot in the list. So we have 0 for A, 1 for B, and 2 for C. And indexes, these indices, are always going to start at 0 in Python. So there are more data types, but these are the main ones that as a beginner you'll need to understand to really get started with using Python. In programming, we have the concept of immutable versus mutable. And what this means is literally the difference between I can change something and I cannot change something. So what that means is immutable data cannot be changed. So that's going to be like your Booleans, your integers, your floats, your characters, your strings. All of these values, in order to actually change them, I would have to create a new one. Right? So I couldn't change the actual value there in place. For example, I couldn't just change this string somehow. I would have to create a new string. Now, mutable data can be changed. Now, this is going to be like your collection types. So when we have a list, I can change the individual values in the list. So I could change this spot right here where it says true to false, for example. We could also count in this same category tuples, sets, and dictionaries. These are all mutable data types that I can actually change their values. Let's talk about data literals now. Now, what literal means is that we have some value that is actually what it says. So in this case, it's a notation for representing a fixed actual value. Right? This means that literals do not represent other values. So when we represent data in Python, we need to be able to represent literals and variables, which we will talk about later. In this video, we're just going to deal with literal values so that we can see what that data looks like represented in Python. First, we're going to deal with null types. Now, null literally means the word nothing. Right? It represents nothing. So our null literals are of the class none type in Python. None is our only literal for these types, and it is our null type. So you may also hear this in other languages as nil, null, none. There are lots of different names, but basically they all represent nothing. Boolean literals. So there are only 2 Boolean literals. This is of class bool, and there is true and there is false. Only 2 states. Make sure that you use a capital T for true and a capital F for false. Integer literals are of class int or int. These are whole numbers, so nothing with fractions in them. Here are some examples, including our negative values that we can have. These are all integer literals. When we deal with integers, there are a couple interesting things. For large numbers, we can use underscores in order to space out the values, and it will not actually return those underscores when we're using them, so it makes it easier for us to read. We can also use scientific values. So scientific numbers we know is, some number times 10 to the whatever power, right? Well, we can do the same thing here. So we have 1e to the 9. What this means is e is the times 10 to the part, right? So whenever this returns, it returns as a floating point number, by the way. That's important to know. It doesn't return as an actual integer, but you use it as an integer. It returns as a floating point number whenever you're doing mathematical operations. Floats are floating point numbers, commonly known as decimal numbers, and this is of class float. Here are some examples that we can look at of floating point numbers. Notice that we can have both positive and negative floating point numbers of varying precision, including this one right here. We have pi and some other important values. We have complex literals. Now, complex literals are of the class complex, and they are special. So complex numbers have a real and an imaginary part. This comes from the square root of -1, and if you've worked in math, algebra, that sort of thing, then you are probably familiar with this concept, and this is where we get the value I from, which is equivalent to the square root of -1. In Python, I is going to be replaced with j for these complex numbers. And here are some examples of these complex numbers that we can work with. Characters. Now, characters have a few little quirks. Here are some normal characters that we might deal with, like A, B, 5 as a digit, right? The @ symbol, the % symbol. Now, we also have the space character. So a space is a character in programming. We also have \n. \n is a new line character. This is a special type of character. \t is a tab character. This is another special type of character. And we'll talk more about these types of characters when we talk about strings later. We also have a few other different characters there. Of course, those are just normal characters as well. Strings, they are of class string, and string literally means a string of characters. So if we take multiple characters, we put them together, we get a string, otherwise known as text for most of us. These things can include digits like from numbers, space characters, all of those special characters we might talk about. Anything that's a character, it can be strung together as a string. Lists are of class list. They are a collection of data that is ordered, mutable, and allows duplicate members. Now, what does that mean? Ordered is having to do with indexing. So every list is going to be indexed starting at the number 0. And what indexes are these are values that allow us to access the members or elements of a list. You can think of this as the things inside the list. So A, B, C, here are going to be our elements, are our members. Those are the same thing. Mutable means that I can change these values. So if I wanted to change any of these values, I would use the index to change it. And then duplicate members means that any of these could have many duplicates, right? So we could have B multiple times, A multiple times, C multiple times, however we needed there. Here's some other values that are also lists that can be stored. You can also take different data types, such as the ones that we've talked about before, and you can mix and match them into a list. All of these are valid lists. Tuples. So tuples or tuples, however you want to say it, are of class tuple. And a tuple is a collection which is ordered, meaning indexed, immutable, allows duplicate members, and uses parentheses to enclose those members. So what that means is here we have a tuple. It is essentially just a list, but instead of a list which is mutable, meaning we can change it, we cannot change the values inside of a tuple. They are still indexed. That is the ordered part. So we start at 0. We have 1 and 2 for our indexes here that we use to access each element. Here are some additional tuples that you can see. They're very similar to what I showed you with the lists. And here we have multiple different data types that can also be stored in a tuple. So again, tuples are essentially just a list, but you cannot change the values inside of a tuple. Sets, so they are of class set, and if we look at them, a set is a collection which is unordered, meaning no indexes. They are mutable, and they do not allow duplicate values. So here we have several different examples of sets. You'll notice that there are no duplicates, right? We can actually change these values, but there are no indexes that we can use for sets as well. One thing to remember with a set is that they use curly braces in order to denote a set. Dictionaries. We have dictionary literals, which are of class dict, that is D-I-C-T. A dictionary is a collection which is ordered. In this case, we are going to index it with a key instead of a number. They are mutable, meaning we can change their values. It does not allow duplicate members, and we are going to use curly braces and colons here to enclose those members. So here's a great example. Here we have 3 keys, apple, banana, and orange, and the values are 5, 3, and 7 respectively. And if we look at some other examples here, we have many different types of keys we can use. Here we have integer keys and string values. Here we have tuple keys and list values. Here we have float keys and Boolean values. Here we have a Boolean key and a dictionary value. So we can have dictionaries within dictionaries. That makes things a little complicated. And then finally, we have mixed key types and mixed value types down here at the bottom to show you we can, in fact, use many different values.